So the problem asks us to simplify these fractions, and that's the same thing as asking us to perform really 6 division problems. So just as an example, if I'm doing part, let's say C, 200 divided by negative 200, what do you get for that question? What does that come out to if I divide 200 by negative 200? Negative 1, yeah. How did you know that? Okay, that explains the negative sign. What explains the 1?
It's 200 and b divided by 200, so really everybody gets 1.
Yeah. So remember, with the negative sign, when the numerator and denominator are opposite, as they are here, we can just put the negative sign out in front of the whole fraction. So that accounts for the negative sign. And then the actual division, the actual arithmetic that we have to do is 200 divided by 200. And what happens when you divide any number by itself? Right. There's only one exception to that rule, by the way, that we're going to get a chance to talk about in a minute. But yes, if I divide 200 by itself, I get 1. Because if I have a party and I order 200 pizzas and 200 people show up, guess what? Everybody's getting 1 pizza. And everybody goes home hopefully full. So yeah, so negative 1. So this is really just a division problem. But your question was, when you were working on this problem in homework, that there was something strange happened on one of these 6 division problems. Which one of these is stranger than the other 5? It's probably, so it's definitely going to be one of these 2 on the bottom here. So the question is which one? So here's the thing. Let's back up a second. So these 2 division problems each involve 0. And the role that 0 plays in these 2 division problems is different. And that's important because, as we already established today, the order in which we divide matters, where the order in which we multiply doesn't. Right? And so which is the divisor, which is the dividend, that's going to change our answer to most division problems. So the first division problem is 2 divided by 0, and the second is 0 divided by negative 7. So I'm just going to rewrite those as division problems. There's a negative sign on that one there. Okay, so let's go back to the division analogy that I keep using, pizzas and people, right? What did we do a minute ago? I'll just do 12. So if I have 12 pizzas at a party, and we have 6 people, and I divide the 2 numbers, I get 2, and what does that 2 represent? Yeah, well, yeah, maybe slices, but I guess I put it as pizzas here, so whatever. 2 pizzas per person, right? So for every person, there's going to be 2 pizzas at this party, right? So that's one of the models that we use when we think about what division actually kind of means. Right? So if we bring that philosophy to the 2 division problems that we have above here, then the one in part F is, let's suppose I invite a party and 7 people show up. I'm going to ignore the negative sign for a minute. And by the way, we know we can ignore the negative sign by just remembering that it goes out in the front in the final analysis. Right? So really the division problem we have is 0 divided by 7, and we're going to treat the negative sign afterwards. So I have 7 people show up to my party, but I didn't pay the pizza guy. We get nothing. The question is, for every person at my party, how many pizzas are there? 0. And so just using that basic pizzas and people model of division, we can convince ourselves that 0 divided by 7 is equal to 0. And by extension, what's 0 divided by negative 7 going to be? It's going to be negative 0. What's negative 0? Yeah. 0 is the only number which is its own additive inverse. Right? It's the same negative as it is positive. Sometimes mathematicians use that fact in proof. It's very interesting. Like, I want to show that something is 0. Okay, I'll show that it's both negative and positive at the same time. Or is both non-negative and non-positive. It's the only number that does that. Okay, so that one's kind of straightforward using this model. So let's think about what this other one means. Here's a party where I remember to pay the pizza guy for my 2 pizzas, but look what happens. Nobody shows up. And I guess that's going to include me, so I don't come to my own party either. It's just an empty room next door with 2 pizzas sitting in it. So some party, huh? So the question is, how many pizzas does each person get in that situation? Well, but it can't be none because there is pizza sitting over there, but there's no people. So for every person at the party, how many pizzas are there? But the framing of that very question doesn't make sense anymore, right? Another way to think about it might be like this. Let's suppose it's kind of hard to use people for this example. How about this? Let's use a slightly different metaphor. Let's suppose that I have, I don't know, $2 million. Now, I would rather have $2 million than 2 pizzas most of the time, depending on where the pizza comes from. I went to grad school in Chicago, and I have the biggest soft spot for Chicago-style pizza imaginable. So I might trade $2 million for one, like an authentic one, but probably not, because I could fly to Chicago thousands of times for $2 million. Quit my job for a few years and do nothing but go eat Chicago-style pizza. Okay, so anyway, $2 million. And instead of thinking about dividing that among people, because I want to keep my $2 million myself, let's suppose that I thought about dividing it up into denominations. I'm not going to use 0 yet. Let me use 5. So I'm just going to, pick a smaller number. And these are going to be $5 bills. Right. So if I want $2 million divided up into $5 bills, how many, my units are going to screw me up here, how many $5 bills would I need to make $2 million? 2 million divided by 5, I'm going to skip over the arithmetic a little bit quickly here if we can. We get, I believe, 400,000. Right? I need 400,000 $5 bills to get me $2 million. What happens if I make this 5 smaller? What if I want to have $1 bills instead of $5 bills? What's going to happen to the number of bills that I need? It's going to go up. It's going to go up, in this case, by a factor of 5. So the smaller that I make that divisor, the larger this quotient ends up getting. Okay, so what if I go from $1 bills to quarters, which are really 1/4, or maybe let's write it as a decimal for once, $0.25 bills. How many quarters would I need? A whole lot more. If instead of quarters I wanted dimes, oh, now we're really getting, I think that's right, 0.1. If instead of dimes I wanted pennies. So take a look at what's happening to this number, this quotient, right? As I make this smaller and smaller and smaller without changing this, the quotient, the size of this quotient is skyrocketing. And what's the end game? So maybe another way to think about it is, now maybe let's think about people instead of money. If I have $2 million and a giant stadium, and everyone who comes into my stadium is going to get an equal share of that money, right? As the number of people that show up goes down, the amount of money that each people get is going to go way up. But by the time nobody shows up, this doesn't make sense anymore. If I have no friends to divide my pizza among, then it doesn't even make sense to say that every person gets this much pizza. Right? And for that reason, that's an illustration of why, we would say that this is an undefined quantity. Right? So I want to unpack this a little bit more, but before I do, the key cue for you in division problems, and this is something that you'll have to think about explicitly now, but it's going to show up in wearing other disguises throughout the semester. When we talk about slope, for example, in our topic number 4, when we talk about graphs, this shows up in our slope conversation out of nowhere, right? So make a mental note of it now. How are you going to remember what's going to be your cue when there's a 0 involved in a division problem? How do you remember whether the result is 0, the quotient is 0, or whether the quotient is undefined? How are you going to keep these two things straight?
If you're dividing something by 0, then it's undefined.
Okay. Yes. So those.
If you're dividing 0 by something, then it's 0.
Yeah. So something, dividing something by 0, dividing by 0. In other words, having 0 play the role of the divisor or the denominator. That gives us an undefined quantity. Whether it's the divisor, whether it's the denominator. Dividing by 0 will give us an undefined result. And then, as you were saying, if 0 is playing the opposite role, so in this example, 0 by something, that's going to give us 0. So pay close attention to what role the 0 is playing in your fraction or in your division problem. When 0 is the denominator, the result is undefined. That's, again, something we're going to meet in several different disguises over the course of the semester. When 0 is the numerator, or the dividend in a division problem, that result is always 0, except in one case. What do you think it is? What's the one problem where 0 is in the numerator, but where the quotient is not 0?